Hey, what's going on there? I wanted to make a video today about um, dynamic blocks and about kind of putting it all together. There might be some concepts I go over in this video that I haven't gone over before, but I'll try to explain everything that I'm doing. What I've got here is a platform that I'm working on. Since I do a CADWorks Steel series as well, this is actually my bread and butter here. Kind of a funky looking platform, but we're not too concerned with the actual design of it, just the implementation of this dynamic block. So essentially what I want to do is make these connection plates where the ends of the beams meet. But right now for me to make this, I have to manually draw it out. And it's time consuming, and I'd like to have, and a lot of these plates are very similar in design. I can use them over and over again with just some minor modification. So what I wanted to do is make a template that I can use in multiple scenarios, which I've done here. So this plate is called a shear tab, and it's what connects some beams together. It's a connection type. I've already created one version of this block that has 2 bolts, but I want to create another one that has 3 bolt and 4 bolts. I've already put visibility states in this block. You can see kind of simply how it works here. In fact, I'll just insert a new block. So I'll hit insert and I'll choose shear tab. The way it's set up is that it's in line with my UCS. So it's because my UCS is set to a top-down view, it's going to insert at a top-down view. I want to set my UCS to a front view. That way when I go to insert this block, it comes in at the correct orientation. So let's use this connection as an example. This one's a little bit different because the beams aren't at the same elevation, but this one they are. So I'm going to put this shear tab work point here. And I'm going to freeze this break so it's a little easier to see. So change my visual style here. I want the shear tab to go here. This is a W8 by 18 wide flange beam that has a C6 by 8.2 channel connecting to it. And I want to put the shear tab right here. But I want to make sure of a couple things. Number one, I want to make sure that the edge of this shear tab is connected to the web of the W8. And that's kind of hard to see in this view. Let's take it from a front view and look. And you can see that right now it's not exactly touching. It's close enough, but if I really wanted to be accurate, or if this beam had a thicker web, for example, let's say that this thing, that's what this grip controls. It controls the left side of this plate where it's going to connect to the web. What I can do is just grab that grip and just adjust this by clicking this grip and then snapping it to the web of this beam. That happens with stretch objects because they're locked to one direction. You can snap them to an adjacent object and they will still snap to that direction. I can click all the way over to here if I wanted to, and it'll line it up with that edge. So the rest of these properties are going to be in the properties menu. They're not controlled with the grips. I have the grips turned off because I want whoever's using this to control the dimensions. I've tried labeling these as succinctly as I can so that people understand what we're working with. I have the hole diameter controlled with a dimensional constraint, so I can change this to like 11/16 and you'll see them get smaller. Go back to 13/16 because that's the connection we're going to use. I've got the dimension from the bolt or from the hole to the center of the beam. In this case, I'm going to put 2.5, so 2.5. And it stretches the whole plate, including the bolts itself. I've got the distance between the bolts. Distance to the first bolt. In this case, I'm going to use a dimension of 1 7/8. That's what it's supposed to be. Where is it at? 1 7/8. Enter. And what it does is it moves the entire plate up. So it kind of preserves this dimension right here from the bolt to the edge of the plate. So it moves everything up. So that's 1 7/8 from the top of basically from the insertion to the first bolt. And then between the 2 bolts is going to be 2 1/4, and it brings in the bolt and the edge of the plate. And now I have my control dimensions for how much taller the plate is past the top bolt, how much taller it is or longer it is past the bottom bolt, and then past the outside of the bolt. So I'm going to leave everything where it's at for now because these settings apply to 13/16 bolts, but I could change them. Let's say I wanted to change them. I could change them to 1 for the top, 1 for the bottom, and then 1 for the side if I wanted to do that. So and it stretches all the plate dimensions inward. I'm going to put them back to what they were. Beyond that, I have my visibility state, and then I also have plate height and width, and you notice that they're non-editable because I put in parameters with no actions so that whoever's working on it can see what their actual plate size is. So let's get into actually editing this thing. So I'm going to block edit and go to edit. These are all the parameters. They look kind of like confusing right now, but we'll get into that. Also, you'll notice I put 2B at the end of each one of them. That's because I'm going to have 3 visibility states eventually, a 3-bolt and a 4-bolt as well. 2B just stands for 2-bolt, and I'm going to have duplicate parameters. So like I'm going to use plate width somewhere else. I'm going to use to centerline beam somewhere else, but I'm going to put 3B or 4B after those. So over here in the 3-bolt, I've got nothing other than the visibility state. So I could make things visible and reuse some things, but I think I would rather just make everything from scratch. A lot of times you can reuse parameters and such if it's gonna be the same in both visibility states, you can reuse them by showing certain objects. But I'm gonna do everything from scratch. So what I'm gonna do is copy. I'm gonna do Control-Shift-C, copy with the base point, set my base point is 0, 0, 0, which is the insertion point of the block. And then I'm going to copy the plate border, which is a P-line, and the 2 holes. And that's it. That's all we have for our actual objects. Oh, I forgot. Sorry. Let me do that again. I also have this text object that says Shear tab, and it's I'll explain a little bit more later on what it's for, but it's to allow me to erase the block, and you'll see what I mean when I actually insert or turn this thing into a real plate. All right, so I'm going to Control V, put my base point at 0, 0, 0, or my insertion point, and you can see there we are. It's relative to the 0, 0, and I got my visibility set to the corner of this thing. All right, so now we can start making parameters. So the first thing I'm going to do before I name anything is I'm just going to start my parameters. I know that I want a stretch parameter that stretches the bolts and this outside edge out to the right. So I'm going to say I'm going to do a linear stretch from 0, 0, 0, 0, 0. And you can't click here. What happens is it's treating it like an aligned dimension, not a linear dimension. If I click here, it's going to want to put it at an angle. So what I have to do is do a linear stretch from 0, 0, 0 or 0, 0, either one, and keep my ortho on. And actually, I think ortho doesn't even apply here. Oh, it does. It does. So I can either use a snap. I'm losing my train of thought right here. What is this thing called? Snap tracking. Thank you. I can either use a snap tracking grip here, or I can use a point filter, like putting in .x and using a point filter. So I'll just put the snap tracking. So now I've got this dimension control going from here to here, this parameter. And you'll notice I'm on parameter sets. I could have done a parameter and then put an action on it, but it's quicker for me in this case to just do a linear stretch. It's a combination parameter and action. I don't need to do separate. Okay. I know that I want this to control, so I'm going to right click on the action and say action selection set, new selection set. I know that I want my stretch boundary to be here, and I want these, actually, I'm not going to do that yet. I'm not going to do any selection sets yet because there will be cases when you'll see here coming up where certain parameters will affect other ones. So I'm going to do all my parameter sets first. So let's do a linear move is what I want to do here, and I want to go down to here. And then that's going to control when we move the entire thing based on this hole. We'll move the entire object. I want to do another linear stretch from here to here, and I want to do a move, a stretch, not a move, because what's going to happen is I want to move this bolt, but I also want to stretch the plate as this bolt gets moved. So I want to do a stretch action on that one. I'm going to do a linear stretch here. Oops, wrong way. A linear stretch from the bolt to the outside edge. And I want to do, that's horizontal plate, the plate limits horizontally. I want to do plate limits vertically, one going up and one going down. So we're going to go this one and this one that controls the size of the plate on the top and the bottom. Okay, and I want to say that's it. Am I missing anything? Let's go back and check. Oh, I need this grip here that allows me to stretch back to the web of that beam, and also I'm going to need my dynamic constraints for the holes themselves. There's something also I'm missing that I just forgot about. I just realized. This is going to be a 3-bolt, so I'm going to need to stretch this down and make it a 3-bolt. So I'm going to stretch this down 3 inches. I'm going to copy this down 3 inches. And I am going to do a linear stretch. So this is kind of some gray area. I have a choice. I can choose to move the entire plate or move just the bolt. I'm going to move the entire plate. So this will control these 2 bolts and the bottom of the plate. This next one from here to here is going to control just this bolt and the bottom of the plate. So I want them to stack on each other because I want the user to be able to control things independently but have the plate follow suit. Basically, if this is a 3-inch difference. If I change this from a 3-inch to a 2-inch spacing, which almost should never happen, these should almost always be identical, but this is, again, flexibility. So if it ever needs to be changed from 3 inches to 2 inches, I don't want to just move this bolt, making this a 4-inch gap. I want the whole thing to stretch, maintaining this as 3 inches, and then this shrinks to 2 inches. So that's why you want to use a stretch function. All right, so now I can make my bottom linear stretch from here to here, and we want to maintain our start and end point. It's important that they start from here and go downward because that's the direction we're going to be moving in when you do a single grip linear stretch. It keeps in mind what your base point is. Because when you look at these parameters, you only have 2 options for your base location, your start point or your midpoint. And this is my start point. Midpoint would be if I wanted the grip to be, the start point to be in the center and it stretched both directions at the same time, which would be like a linear pair. Okay. So the last thing I need to do is my dynamic constraint or dimensional constraint. We're going to do a diameter because I want to use the diameter of these holes. So we're going to put one here. We're going to put one here. And we're going to put one here. Oops, no, that's fine. All right. And also that last parameter set, the linear stretch, where I want it to go, I want to say I had it going from like here. It really doesn't matter where it goes. We're just stretching this backwards. So I'm gonna put it from the bolt to here. Okay. I think that should cover everything. So yeah, it looks busy and no parameters have been assigned, and nothing's been named yet. So let's start by naming so we know what's what. We're gonna go to centerline beam, and actually we want to be centerline of beam 3B. I'm just going to copy this since I'm going to reuse this 3B over and over again. Let's make sure that's what I have over here. To CL beam 2B, to CL beam 3B. This is plate edge. I'm just going to actually copy these. Why not, man? Plate edge horizontal. This is kind of the tedious part, so bear with me. Oops, it didn't let me change the name because I didn't change this to 3B. Okay. 2-bolt, copy this, plate edge top. Change the 2B to a 3B. I may wind up cutting this part out. I don't know. It's kind of a tedious process. But you see, essentially what I'm doing is I'm giving these parameters the same names, but I'm just changing the last part of it. No 2 parameters can have the same name. Every parameter has to be unique in its name, no matter what it is. It will auto-name for you, as you can see, diameter 2, 3, and 4. It starts off at 2 because I already have a diameter 1 here. And I'll show you why I didn't need to give that a custom name like the other ones. So And actually, none of these will have custom names either. You'll see why. It's a cool thing about dynamic constraints. They can use expressions where parameters cannot use expressions. All right, so this is going to be to first bolt. And we're just naming all these parameters so that they make sense when somebody modifies them in the properties. And now we got, here's kind of another thing we've got. We've got between bolts. We're going to call this, so this is going to be between bolts, but this one's going to be a little bit different because it's going to have to say between bolts 1. Oops, I keep messing up. There we go. Between bolts 1 and between bolts 2. So the person knows you're talking about, you know, going from the first set of bolts and the second set of bolts. And that's it. We've got all our custom names except for these. So looking at this one, you'll notice what happens is rather than having two separate functions or that I have to control, if I had each one of these as their own, like hole diameter 1, hole diameter 2, in my properties menu, I'd have to define the diameter for every hole. But what happens is with these expressions, I can say, make the diameter, this is diameter 1, that's the parameter name, or the constraint name. I want it to equal hole diameter 2b. That's what I've named this one. So hole diameter 2b, which is the name of this parameter, is equal to 13/16. I'm saying I want the value for this to equal whatever that one is by putting that name in here. So what happens is I can actually copy this hole diameter 2b, come over to here and say that I want this expression to be also hole diameter 2b, and all of these will match whatever hole diameter 2b is. Now my only concern, and I'm gonna test this out right now, my only concern is because hole diameter 2b as a parameter is not included here in this visibility state, will I be able to control it, or will I have to go back to the 2-bolt visibility state? So let's test that out real quick. Sometimes when you go to test, it's not in your view, so you have to do a zoom extents. All right, so here I am in my first visibility state, and you can see the very top, hole diameter 2b is my first parameter. That should be there on the next one, but if it's not, then we have a problem. So there's all I haven't turned my grips off yet, so they're all still there. Do we see hole diameter 2b? We don't. So because we don't see hole diameter 2b, we're going to have to use hole diameter 3b. But you'll notice, like, let's say I made something kind of unruly, like hole diameter, make this 1.5, so they're massive. If you look, when I go over here, they're still 1.5. That's because I had them use the value of hole diameter 2b. So I'm going to close this out. And I'm not going to have these used. We're going to call this hole diameter 3b. And I wonder if I can do like the dimension thing. No, 0 feet and 13/16 inch. Okay, so I'm going to have this equal hole diameter 3b now. So because I've named this parameter hole diameter 3b, I'm now saying I want this parameter and that parameter to both equal whatever this is set to. So if this gets set to 1/2, you better change these to 1/2 because you're now supposed to be equal to whatever this parameter is. So you can reuse it over and over again. Now the user doesn't have to put in multiple parameters. Super nice. Also of note, I believe dynamic constraints are the only way you can scale up these holes by using dimensions. You could fake it in using a scale function, but it would be kind of tricky. So I wouldn't recommend that because you got to use scale factor instead. Okay, now we want to turn these grips off. We don't want to be able to manually edit these. You want to turn grips off for almost everything because you don't want to be able to manually edit this stuff. So we're going to start with the holes, set their grips to 0. now they can no longer be controlled with grips. We want to set everything here to be controlled by properties only, except for this grip here. So I'm going to select all these parameters and change all of their grips to 0. The only grip I actually want is the visibility state and this one. Why this one? Because it's not easy to ascertain the dimension from here to the web. You don't want to have to like go do it. You don't want to have to go and like measure it out. You don't know what it is. That web changes all the time, that web thickness. So it's easy to just grab this and snap. But everything else, you're probably going to know the dimension of. You're not going to freeform that. You're going to know this actual dimension here and this dimension here. That is at least in steel design. So you're going to pretty much know what these dimensions need to be by their actual numbers. So you're going to input those rather than to just drag it to some random number. Okay. So now we need to actually start specifying things. Now, your CAD may have done this. It may not have. Mine's kind of been glitching out on me, and I probably would have been better off making this in regular AutoCAD and not CADWorks, but since I'm making a plate out of this, I'm in CADWorks. But you'll notice that all of my parameters are overlapping, or my actions, which kind of sucks. So for the time being, I'm going to drag them where they need to be. So this one, if you put your mouse over it, you'll see what it's modifying. That red X shows you that it's stretching. That's the side that it's going to be stretching on, and the whole parameter kind of gets a little bit thicker. So this one goes to here. This one is going to go right here. This one is 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 down here. And this one is right here. And that's it. All right, we're good. Let's start at the beginning. Action selection set, new. This is a stretch action. So I want to stretch it from here. All this stuff is what I kind of, you really don't have to stretch the parameters in. They really don't need to be, but I'm going to do it just for posterity. I'm also going to select everything that's included in this. All right, now by doing that, I'm stretching this parameter, because I want it, when the bolts move, I want this parameter to move. I'm stretching this stuff. I want it to move when stuff gets stretched in. What that means is whatever I set this distance for this bolt at, everything's going to move that distance. It's going to be set to that. Okay. Now let's set the distance to the first bolt. So action, new selection set. This is a move function, so I'm going to move everything except for the top two. And again, they really don't matter at all. I could move them, they don't have to. This needs to be moved because it's tied to this stuff here. Horizontally, it's tied to it, or vertically, I guess you could say. So it needs to be moved with it. But these are horizontal, they don't have to move with it. Anything horizontal doesn't need to be moved. This one I want moved because I want it to stay relatively near the center of this plate, this grip dimension. So we're going to complete that. Now everything here will move when this dimension has been input or changed. The distance between these two bolts, this is a stretch parameter, so I want my stretch window to come up here. I'm going to include all of this stuff, including the bolt. I don't need to put, this is kind of one of those gray areas. I don't need this grip to move per se. I want it near the center, but it didn't have to be moved. So I'm going to leave this grip and this parameter out of it. This will cover everything else though. It'll cover this parameter, that parameter, these two holes, this parameter, and the bottom of the plate gets stretched down. So that takes care of that. Now I'm going to do the exact same thing with this one, except I'm only going to include one bolt and the parameter for that bolt. So those should stack on top of each other. This parameter will modify this one, so it'll all do it together. Hopefully, luckily, it does not compound it. So, all right. Now we've got this end, new selection set. I'm just going to grab the plate at the end. So I really just want to grab the plate. So I'm just going to hit the actual plate itself because I want to just stretch this plate by itself. Same thing with these. I'm going to grab the plate. My boundary box will be here, and I just want to move the plate upward. However, I would like from my visibility state to move with the plate. I want it to always be on the corner, so I'm going to select the visibility state as well. So Now here at the bottom, same thing, boundary box, select the edge of the plate, and you don't have to hit the parameter because this is what we're modifying. You can, but you don't have to. It doesn't do anything. All right. So also, when I go and test this thing, you'll wind up seeing that visibility state here has, I'm not sure why I've got an error message on the visibility. It needs no attention. Oh, it's not for that one. It's for 2B. Let's take a look at plate width 2B. Is that this one? No, that's the horizontal. That's the move. This is plate width 2B. Yeah, I'm going to modify the selection set. Make sure we got everything selected. Yeah, everything here. Oh, I'm tripping. These don't have parameters next to them. So that was my last thing, is I want to be able to see what the width of this plate is after we've made modifications to it and the height of the plate, but I don't want to be able to, I don't want somebody to be able to modify that. So what I'll do is just put in a parameter. I'll put in a linear parameter, linear, however you say it. And I'm going to leave it like that with no grips. So somebody cannot modify it. It will show up in the properties, yes, but because it has no action associated with it, there's no way for somebody to input information into it. So all it's going to do is return that value like a dimension. Same thing with the vertical. I'm gonna change, what did I call this on the 2-bolt? Plate width 2B. So I'm going to call this plate width 3B. Okay, and same thing for the vertical. I think this is a plate height or something like that. Plate height 2B. I'm going to change it to plate height 3B. Okay, and I'm going to turn the grips off on this one as well. And that's it. There's no selection sets or anything like that, something to pick or bounding boxes, because there is no parameters. And you're going to get this exclamation mark because it's letting you know, hey, you've got a parameter here with no action attached to it. So, but now all my actions are back here in the middle and all that. So, but we should be set. We're going to go test this now and see what portions don't work. But everything here should be tied to something. All right. They also might be out of order, but we're going to fix that order in a second. So let's go to test. Actually, I'm going to close this and save it so I don't lose all my work, because I did a lot of work and I don't want this. Stuff does happen, stuff crashes. All right, we're going to test this block now. All right, so we've got our 2-bolt. Now we've got our 3-bolt, okay? Shear tab did not move down this thing. That's okay. I'm not hugely concerned with that. I didn't include it in any of my selection sets, so it didn't move. Or maybe I did include it in some selection sets, but not others. So here's all of our variables now. Looks like a lot, but it's actually not too bad. First one is our visibility state. The next one is our distance to the center of the beam. Let's set this at 3 inches and see if everything moves. Okay, nice, but visibility state moved with it, and I did not want it to. So I'm going to have to go make sure I remove that from the selection set on that parameter. Let's put it back at 4 inches so we can kind of see, make sure everything works. All right, distance to the first bolt, I have at 2.5. Let's put it at 3 inches. Perfect. Our plate edge distance, let's say we got to make this at like 2 inches. That's gonna change the right side of the plate. Perfect. The plate edge top, let's put that at 2 inches. Perfect. And my grip for the visibility state went with it. Great. Okay, between bolts. Now these are out of order, right? So where's my first set of between bolts? Here. Let's say these got to be 4 inches. What we should expect to see is this moves down 1 inch, but then also this moves down with everything. So let's get over there and do that. Change that to 4 inches. Between bolts, 4 inches. Perfect. Everything moved. The bottom one didn't move yet because I didn't get stretched any further because I haven't done that one yet. So let's change that one to 4 inches. And that moves as well. And the plate goes with it. And that's what we want. We want the plate to go with it. By including the plate or the boundary of the plate in our selection sets for both of those parameters, they both get moved down when the dimension increases. Plate edge top is set to 2. Plate edge bottom will set to 2 now. That controls that. Now look, if I go back and change these things to 3, it'll still get moved back up, which is like super, super awesome. That was between hole bolts 1, between bolts 2, set to 3 inches also. And so we're getting independent control, which is exactly what we want. Hole diameter 11/16, which is perfect. So the hole diameter changes. And then distance 9. So distance 9 is probably this distance right here. Let's see. It is. And we have a couple of problems with this. So I may have forgotten to set up the selection set. It's obviously not controlling anything. So what I have is probably an action and a parameter that's not actually tied to anything. It's also reporting its dimension, and I don't want it to do that. I want that to be controllable only with the grip, but not show up in the properties because I don't want to confuse anybody. So we're going to close this out. Let's go fix that first. So let's move this stuff out of the way till we find that parameter, distance 1. That's it right there. I'm in 2 bolt. I just realized that. My bad. Okay, let's try this again. There it is. And there's the marker letting us know, the icon letting us know there's no selection set associated. This is a stretch action, so we're going to say new selection set. Put it right around here. I want the visibility state to go with it. I want this to be, oops, wrong one, but that's okay. It's the parameter I clicked. And I want the bounding box to go with it. So we hit OK. Now it's going to stretch the bounding box, or it's going to stretch the left side of this plate, and it's also going to move the visibility state with it. I also do not want it to show up in properties, so I'm going to say no, but I do want that grip to show so they can grab it by grip. I also was having a problem when I changed the plate width that it moved the visibility state. That tells me that my selection set included the visibility state when it should not have. We're just moving things around until we find it, and there it is. That's what I want to see right here. And it includes the visibility state. It gets a little thicker, I can see it. So I'm going to say action set, modify selection set, and down here, it's asking for the frame, the bounding box. I want to keep it the same, so I just right click. Now it's asking me to select an object to add. I want to click remove or hit R for remove. And now I can go click visibility, and it will remove visibility from the selection set. And I think that's it. Let's test this again. Select 3 bolt and go to our properties. Now when I change the distance to the center line of the beam to 2 inches, visibility state doesn't go anywhere. Well, it shouldn't be 2. It should be something like 3. It's a little bit excessive, but there you go. There is a way to keep this shear tab word centered, but seeing as how it's really non-essential, I'm not really concerned about keeping it centered in the plate because it's just there to allow me to delete. And I'll show you that at the end when we insert this. One other thing, let's go back to the 2 bolt. You'll notice on the 2 bolt, remember what I mentioned earlier, I said that if I were to change, like this is probably fine, I can change this to 3 inches and it works fine. But if I were to change the distance to the first bolt, I think it was, that it wouldn't be affected. Right, so because it wasn't tied into that. So let's close this out, and that's because over here in the 2 bolt, on my distance to the first bolt, which is not that one, or that one, or that one, or that one, or that one. There's a lot of them here, aren't there? Where are they all at? I feel like I'm missing one. There. That's the plate top. That's between the bolts. That's that one. That's the move function. Oh, that's it. That's it. I don't know why I didn't catch it earlier. It's a move function. So I'm going to say modify, and I want to add. So I'm just going to select this visibility state. There we go. Now it's added in. So now when I go test this, and I go hit my selection, or my properties, and I change that distance to the first bolt from 2.5. From 2.5 inches to say 3 inches. The visibility state moves with it. So, oops, this is what I wanted to change here. All right. Now you'll notice that things here are in a much more neat order. I have these set up in a way that it's a logical order. When you select this block, first thing you do is set your bolts, your hole size, your hole diameter. Then you'll set the distance from the bolt to the center line of the beam. So you'll say, oh, this is going to be 3 inches from the bolt to the center line of the beam. And then you go to the distance to the first bolt. Oh, I want this to be 3 inches to the first bolt. And then you say, what's the distance between the bolts? Oh, I want it to be, I don't know, 2.5 inches. You know what I mean? Then you go to the plate. What's the distance to the plate top? I don't know, 1 inch. What's the distance to the plate bottom? 1 inch. Plate to the side, 1.25 inch. It's a logical order, and then even visibility state should be at the very, very top. The second visibility state, hey, what happened? I just realized somewhere along the way that visibility state got off kilter. So let's figure out which one of these broke it. I'm going to guess it was plate edge top. Yeah. Plate edge top needs to control that. Also, when I click over here to 3-bolt, you'll see that the order of things is kind of really out of whack. Visibility state's first. To the center line of beam is great. To the first bolt is great, and then for the first set of bolts is great. But I really want the next set of bolts between bolts 2 right after it, and then plate edge top should be before plate edge horizontal. Hole diameter should be all the way up here. So they're kind of out of order, and also I don't want diameter 3 and 4 being shown. So we got a little bit of tweaking to do. These are one of those things that you just have to tweak it. You really tweak the hell out of it to make sure that it looks good for your end user. So we're gonna go back to I'm gonna go here. Plate top I said was modifying the visibility or not modifying the visibility state, and I wanted it to. So I'm gonna grab that. Let me make sure I did that same thing here. The top, I'm pretty sure I did. I did. It's highlighted. Okay. And I want to make sure first bolt is also set that way. And it is. So diameter 3 and 4, both of their properties need to be set to no. We don't want to show that. We only want to show the first one because that's what's going to control the other ones. Let's see. What else were we going to do? The order of things. That's your parameters manager. Now, when you first start a dynamic block, your parameter manager will have no order. All the stuff will be blank. The first time you attempt to set an order, it's going to try to auto number for you. You can keep numbering things on your own to provide an order, and it will just renumber what's left. It will, whatever you put in, it's going to maintain that. You put it, it keeps it. So now what I can't do is move them up and down this list, which kind of stinks, right? I know that I previously had 9 parameters. I just know that. So starting with parameter 10, my visibility state really needs to be my first parameter number. So wherever my visibility state is, let's put it as visibility state number 1. You're going to see that hole diameter 2B will get numbered to 2 when I do that. It pushes everything down the list. Okay, so I'm going to start at parameter 10. Let's find parameter 10. There it is. That's distance 1. Oh, that's actually from the, maybe I did have more than one. It's going to be probably parameter 11. Oh no, I forgot to add a couple extra. Plate height 2B, plate height, let's see, where's 12? 12 is here. Plate width, so where's 13? 13. To center line of beam 3B. So this is where I want this to be here. 13. Actually, I want the hole diameter 3B to be 13. So watch, this is going to go to 13, and this is going to go to 14. This is going to go to 15, which I actually want that order. So I'm going to say I want my hole diameter first. So this is going to be parameter number 13. This gets changed to center line of beam is what I want next. Perfect. And it's going to be 14. To the first bolt will be 15. I like that. That works. After that, I want the between bolts 1 and 2. So we're going to set, let's find between bolts 1 and 2. So we're at parameter 15. I want 16 and 17. Between bolts 1 and 2. There's 16. That's good. I want this at 17 now. Okay. I want my plate width. Is it the plate width? No, I want this dimension here, the plate horizontal. I want that to be 18. So where's my horizontal? Horizontal, 18, perfect. I want my top to be 19. It is. My bottom, where's my bottom? To be 20. It is. Perfect. Things are looking good. And then, is that it? Yeah, that's it. Because then we're going to have plate height, plate width and height are going to be 21, 22. Plate width is going to be 21. Plate height 3B is going to be 22. I know this is tedious, so if you're hanging in there on this, kudos to you. This is the minutia of dynamic blocks. They are tedious, unfortunately. So this is what you're working with, you know, but it's a trial and error. I'm trying to get you to the point where you can see, I want this block to function the way it's supposed to function and be organized so that when you go to do yours, you'll understand how this stuff gets this way. I probably could have used a much easier example, but I'm already working on this dynamic block right now as it is. I figured I would show you how we got there. All right. That should be the order of things. Where's 23 and 24? 23 and 24 are these two, but they're not even being shown. It's cool because when you click it, it'll show you too. So diameter 3 and diameter 4, those aren't even being shown. So I'm okay with theirs, you know, not showing. I mean, being last like that. So you can also change whether you want the. You can order. I just realized you can organize it by. There we go. There's order. Haha! Look at that. You can organize them by order. So this kind of shows you the logical order that I have them all in. And if something looks like out of order for whatever reason, then you can always modify it. All right, let's go ahead and test this block. I've talked enough. Let's go to 3B, directly to 3B, and see if we can 3-bolt and see if we can get what we want. Visibility. I got my hole diameter. I like that. I got the distance from the center line of the beam to the bolt. Perfect. This direction. I've got the distance to the first bolt, 2.5 inches. Perfect. Between the bolts, 3 and 3, 1 and 2. Here we go. The edge distance horizontally and the edge distance on the top and bottom. And then I got the width and the height. Perfect. I've now organized these in a logical manner. That's how you do it with that parameter manager. The only thing I'd like to do to this is that I realize I kind of screwed up. On a 3-bolt shear tab, your first bolt is most likely going to be 3 inches. So I want to go back and modify that. So I'm going to close out of this. I don't know why I tried to go to the block editor. Close out of this. And what I want to do is I want to stretch this. I'm going to do a kind of a lasso stretch. Can I not do a lasso stretch here? Oh, this is an older version of CAD. There is no lasso stretch. So I'm going to do a stretch with the crossing polygon. Turn my ortho off and turn my O snap off. I'm going to get up in here. Oh, you know what? I don't have to. I can do it from here. I'm going to put everything down 1/2 inch. And there we are. So now this default parameter just changed, but that's okay. If I look at my parameter manager now, where this first bolt 3B used to be 2.5 inches, it should now be 3 inches as the default expression. So where is that parameter? To first bolt, there we go. 3B is now 3 inches because I stretched it down manually. So there we are. I am where I want to be. Actually, I just realized I messed up. I should not have stretched. I shouldn't have stretched there. I should have stretched the entire thing starting here. 0.5. There we go. Because we want to move the whole plate down. Because I want to keep the top and bottom the same dimension. All right, there we go. I'm done. I will do the 4-bolt one later on my own. So we're going to save changes. I am now done. I can now change this from a 2-bolt to a 3-bolt. Unfortunately, I don't have to do a 3-bolt right now. So what we're going to do is a 2-bolt. All right, let's get the dimensions. Actually, the dimensions I need are still saved. Let's reinsert this because my grip's not where it needs to be. Let's see if we can. Let's see if we can't break it if something didn't happen to it. So we're going to insert, shear tab, hit OK, get my insertion point right at the end point of here. And look, it's already off. Why is it off? Let's go find out. It's off because these two aren't starting in the same location. visibility state is the same in every every visibility state. The location of the parameter is the same, so it's always going to be the same no matter where I put it. So I'm just going to leave it alone. It's fine. I'll leave it default like this. Save changes. So it's fine here, but it'll look kind of goofy here because it won't be the same. But honestly, I don't care at this point. I can live with that. All right, so parameters. I want this to be 2.5. The first bolt I want to be 1 7/8. That's dimensions that I know to be true for this plate. I want the between bolts to be 2 1/4, and I think I want what's the plate height set at? 4 3/4. And what is the go by that I'm using? 4.5. And I've got this at 4 3/4. Yeah. So what that means is that the top is going to have to be 1 1/8 inch. Bring that in a tiny bit. This is going to be 1 1/8 inch for the bottom. And now we've got 4 5/8. That's still not enough. We're going to have to put these at 1 1. No, that's right. 1 1/8, 1 1/8, 2 1/4 is what my center is. Plate height. Let's make sure that we're, and this is why you got to double check your stuff. Let's make sure we're at 4. We're at 4.5, and this is reporting. That means I broke the chain somewhere. It's reporting 4 5/8. So let's take a gander at what broke the chain. This is my plate height. Let's make sure that everything is affecting it like it should. So I'll do a regen, make my stuff show up. All right, this is one of them. Is it affecting it? Yes, it is. It's part of the set. We don't need that one. Is this one affecting it? No. And there's my problem. This is not included in this selection set. So let's close the block editor and see what we got. Booyah, 4.5. Perfect. All right, I like that. I like that. So we're good to go there. So now what I can do is I can turn this into a CADWorks plate. So if you're watching this for the dynamic block portion, you probably tapped out already, whatever. But if you stuck with it this far, this is the CADWorks portion, which isn't very long, but I'm just going to make this into a CADWorks plate this is really meant to be a template, not for me to explode it or anything, although I could explode it. Actually, I absolutely can explode it now that I'm thinking about it. So what I can do is hit explode. Everything disappears. Dynamic constraints, everything's gone. And now that I'm thinking about it, I don't need the shear tab text anymore. The way this was working a little while ago when I was using actual constraints is that I would use it as a template, draw a rectangle on top of it, draw 2 circles, and that would allow me to create a plate, a CADWorks plate that was 3/8 of an inch thick. And I would extrude these, and I would do a subtraction, and there we go. But now, because the plate is overlapping the block, I had no way to erase it other than like selecting everything and then deselecting the plate portion of it. So it was easy to just click the text and erase the block. But since I no longer have the constraints that I had before, because when you explode a block, constraints will stay behind. It's kind of ugly. But I no longer need that. Now I can just explode this whole thing, erase the text, and just turn this into a plate at 3/8, and then extrude these. And there we go. There's my plate. Now I can match properties. And there's my shear tab plate. Exactly what I needed after the fact. So that just became a template for me to create this plate very quickly as it adjusts in parameters. Now, where am I going to use that 3 bolt? Well, let's say I got, 2 W14 beams, which are more likely to use the 3 bolt. Let's slow 1443. Where are you at? All right. Here's a 14. Got to change that UCS. Let's put in a 1443. Now let's put another 1443 going the opposite direction. All right. Let's do a cope. Bolted cope. All right. But now let's put in that shear tab. So UCS front, insert, shear tab. Snap it right here. Let's change that to a 3-bolt. First thing we're going to do is grab that grip and snap to here. That moves this line over a little bit. Now it's right on the edge. And now we can, and it's probably going to stay like this. I don't have to make any adjustments. That's what's kind of nice about it, is I set this up so that it's going to use pretty much standard default dimensions. I can just leave this alone as is, explode, erase, and then I can use this as a basis for a plate. 3/8 shear tab. I'll have my default dimension from these holes to the center line of the beam at 4 inches, which is pretty common for most of the connections that I do. Oops, I did not subtract that properly. And there we go. There's my shear tab. Quick, easy, painless, done. Quickly throw a shear tab in there. If I want to, I can go a step further and put circles on the beam, do extrusions and subtract those, do all together. Now I've got a hole through the beam as well. Did I not do the maybe I picked the plate instead. Let's try this again. Subtract. Nah, it's there. What am I missing here? Oh. There we go. And I think this plate is not... That's right. That's the one caveat, is that there's no way to control the dynamic block in the z-axis, so this will have to get moved with using a point filter to the face of this beam. And you can see that now it's like lined up. That's the downside to using. Oops, let me go back. That's the downside to use to dynamic blocks, is you cannot edit in the z-axis. So my original dynamic block. Let's go back all the way to the beginning here. The original dynamic block here was brought in right on the center line, but it really should have been moved in the z-axis to the face of this beam, this web. But you can't put a z-axis parameter in dynamic blocks. So I had to work with what I could using the x and y axis. So that's the one caveat for this. But it still works well enough, and I'm happy with that. So I could have maybe offset it in the beginning in the z-axis, but then it wouldn't have accounted for the different size webs. So anyways, that's it. That's basically the dynamic block in a nutshell, and how I can use it to create these shear tabs. That's kind of a lot of different things being put together. You can see how these dynamic blocks can assist in situations like that. So if you've hung around this long, kudos. Hope you learned something. Later.